Let's go ahead and try to solve this problem. The problem here is there are three different ethers, and the question is give two counterparts how you would synthesize these ethers. As you know, ethers are synthesized by Williamson Ether Synthesis. For that you need an alkoxide, appropriate alkoxide, and you also need an alkyl halide. That means, for example, if you are trying to see this isopropyl ethyl ether, the way you will synthesize it is by breaking it down either here or here. If you cut it here, the alkoxide would be the isopropyl side, but if you cut it right here, it will be the ethyl oxide, etoxide would be the counterpart. As a general strategy, you always need to have the alkyl halide as a primary, maximum as a secondary. That means the alkyl halide should be a very unsubstituted, less bulky counterpart. Let me do this now. For example, if I do here, if I cut it right here, I'm suggesting that the alkyl halide, for example, a bromide, plus an alkoxide like this. This will not be the best combination of making that ether, even though it can attack here by substitution reaction. You ought to have the primary alkyl halide the other way. For example, if you just cut it the other way, if I cut this on this side, that means the alkyl halide would be the bromide right there, plus the alkoxide would be on the isopropyl oxide. So this is the best combination, where you have a primary alkyl halide and you have the alkoxide. So that would be a good combination. This would not be very favorable. This is favorable. For example, in this one, let me cut right this, and I would get, by cutting it right there, the alkox, for example, the chloride, let's use a chloride alkyl halide, plus the alkoxide would be the propyl alkoxide. Here I'm creating a secondary alkyl halide, but I have a chance